Problem D. In a group of 80 infected people, what is the probability that the average incubation period for the whole group will be less than 12 days? Again, we'll draw a picture. We'll mark our mean at 12.7. We're being asked less than 12 days, so we're going to go left from 12. So we'll make a mark for 12, and we're interested in the left piece. Now, once again, we are being asked to find probability because the question says, what is the probability? So once again, we are going to use norm.dist. And we're also given that we're looking at a group of people and we're looking for the average incubation period for those people. Because we're looking for an average incubation period, we'll use x, comma mean, comma standard deviation over square root n, comma true. From this, we will get p less. Now, we're not interested in being greater this time because the question says that we want the less because we shaded on the left side of this graph. So once again, we'll collect our pieces. We need x, mean, standard deviation, n. Our x this time was 12. Our mean was 12.7, standard deviation 4.3, and n was 80. Now, for p less, we'll say equals norm.dist. Click x, comma, mean, comma, standard deviation divides square root of n, comma, true. Press enter, and we can find that our probability of being less than 12 is 0.07269. This will be our answer for part D. Problem E changes the wording. Now, our x value is still 12 days. We are still looking for probability. But now, we're not being asked about a group. We're being asked about a randomly selected person. So this time, because we are not looking at a group, we will not need to use n in our formula. However, our bell curve will be the same. Our mean is still 12.7, and the marker we're looking at is less than 12 days. We'll shade in the left-hand area, and now we'll redo the problem without using an n. Remember, for norm.dist, our list is x, mean, standard deviation. This will give us the probability of being less. The x value is 12, mean is 12.7, standard deviation is still 4.3, and like our other problems that we've done previously, we'll say norm.dist x, comma mean, comma standard deviation, comma true. When we press enter, we'll get a probability of 0.43534. We don't need to do any more work on this problem. This will be our answer for problem E. Problem G asks, determine the range of average incubation times that might be considered usual for a group of 49 infected people. Now, to find the usual range, we need to find the significantly low values and significantly high values. Now, ordinarily, our significantly low value would be the mean minus 2 times the standard deviation. And the significantly high would be the mean plus 2 times the standard deviation. However, we are not looking at individuals, we are looking at a group of 49 infected people. So we're going to again make an adjustment to the standard deviation and divide both of them in the significantly low and the significantly high values by square root of n. So that our equation for significantly low is now mean minus 2 times standard deviation divided by square root of n. So in those equations, we have mean, standard deviation, and n. We'll make a space for them in Excel. We enter that the mean is still 12.7, the standard deviation is still 4.3, and the n is now 49. Let's make a space for our significantly low value, and one for our significantly high value. Our significantly low value is mean subtract 2 multiply standard deviation divide square root of n. And we get 11.4714. We'll do the same thing again for significantly high. Mean plus 2 times standard deviation divide square root of n. We press enter and get 13.9286. So let's draw our bell curve one more time. Our mean will be marked here in the middle again at 12.7. Our significantly low value will be over here on the left side, leaving a small tail on the left at 11.4714. This will be significantly low. The other marker will be on the right at 13.9286. This will be significantly high. And in the middle, inside of the 2 lines I've drawn, will be the usual range. So we can say that the usual range goes from 11.4714 to 13.9286. You may also see this range written this way. Some people write this with the low number. They write a less than or equal to sign and then an X and then another less than or equal to sign and then 13.9286. This means the same thing as what we just wrote. It's just written in algebraic form. So if you see the brackets, that's called interval notation. If you see less than signs with the letter X, that is algebraic. In statistics class, you'll see it written either way, so don't be too surprised if you see these strange symbols sometimes. All this means is that the lower number is the bottom of our usual range, and the number on the right is the top of our usual range.